All right, Unit 9, Day 2.
I did study a little bit, but it still doesn't analysis of all.
So this seems like an odd title, maybe. Unit circle problems without the unit circle. So today we start shifting away from, and you guys mentioned that yesterday's assignment was pretty easy because all you did was like stare at the chart and write down the answer, like what's the big deal. Today we're going to get away from that and learn how to answer the questions without staring at the unit circle. Because as we go through this rest of the semester, you're going to need to know these values, and you're not going to need all of them all at once, so it's not worth it to like write out the whole unit circle and then read off what you need. We need a faster, better way, and so that's what we're going to do today. Let me remind you, we did this in warm-ups, but just a reminder, cosine is 1 over x, or excuse me, secant is 1 over cosine. I have trouble with 1 over cosine today. Secant's 1 over cosine. So if we ask you for secant, those should be the same variable, then you take the x coordinate and you flip it over. So it's not really anything extra other than flip it over. Cosecant goes with sine, so you take the y coordinate and flip him over. And cotangent is 1 over the tangent. Tangent's y over x, so if we flip that over, we do x over y. So now we know all of the 6 trig functions from the unit circle. Cosine goes with x, sine goes with y, tangent is y over x, and then the others are all reciprocals. So as long as I remember who they're partners with, it's not a big deal. All right, here's I don't know how to phrase this. How to answer the problems without having a unit circle right next to you. How to work without a unit circle. So, if you've got your unit circle next to you, most of you do, turn it over. We'll see if we can do this without looking at the unit circle. Obviously, you'll have it, so if you want to check your answers as you go, that's fine. But don't stare at the unit circle while we do this, because we want to get to the point where we can do it this way rather than the stare at the unit circle way. So take one last look at it, flip it over, and I'll walk you through how to get there without staring at the unit circle. So let's find the sine of 11 pi over 6. Okay. First of all, I don't expect you to have that memorized, right? I don't have that memorized. For me to find that, I need to think through what I'm about to show you. The first step is to locate the quadrant. The second step kind of goes with it, so I don't want to draw it out yet, is the angle, the shallow, the middle, or the steep angle. So those two kind of go together, quadrant and angle. That will allow us to draw an accurate picture of 11 pi over 6. So, 11 pi over 6, what quadrant is that going to land in? 4. Well, how did you know it was going to land in 4?
It's close to 12 over 6.
Okay, it's close to 12 over 6. It's almost 2, so it's almost all the way around. So I know that this one's going to be in quadrant 4 because it's almost 2 pi. Right? All the unit circles are just barely above 0, almost to 1, just bigger than 1, or almost to 2. So it's not difficult to locate what quadrant you land in. So quadrant 4, is it shallow, middle, or steep angle? this one you may not remember, that the shallows are all, it has to do with that denominator. Anything over 6 is a shallow angle. Over 4 was the middle angles. And over 3 are the steep angles. So I'm going to draw my angle in the fourth quadrant as a shallow angle. Fourth quadrant, shallow angle. Next, I'm going to label the sides. Well, I don't remember what side lengths are. Well, there's only 3 choices. The short sides are 1/2. The medium sides are root 2 over 2. And the long sides are root 3 over 2. Well, the medium only goes with the pi over 4s, right, when they're equal to each other. So I know it's not that. And then because I drew the picture accurately, meaning in the right quadrant and it's shallow, I can just tell by looking that that's the short side. So that's got to be 1/2. That's the long side. So that's root 3 over 2. Now there's one thing that's not quite right about that picture that I need to be careful about. What is it?
Oh no, I have a question. I'm not answering that.
Okay. Does anybody see what's not quite right about my picture? About these side labels that I put on there?
What about the hypotenuse?
Hypotenuse is always 1, but that won't matter because we never use it.
Oh, it needs to be negative.
It needs to be negative because it was down. So be careful with the negatives. Question.
When you say steep or shallow, which one is closer to like the x-axis or y-axis?
So
Because I got confused.
Yeah, that's okay. Shallow, and you can think of it that way. The shallow angles are close to the x-axis. The steep angles are close to the y-axis. And the middle angles are the ones in the middle. That's another way to think of it. All the over 6s were close to the x-axis. All the over 3s were close to the y-axis. All right, so back to this question, the sine of 11 pi over 6. Which coordinate do I use for sine? X or y? This was the warm-up. Sine goes with y, so I need to grab my y coordinate, but it's negative 1/2. I already have it labeled. Now, obviously that takes a little bit longer than just staring at the unit circle and grabbing the value. But you think about all the time it takes to build the unit circle, and if you just need a couple of these, this is going to be better than writing the whole thing out. So here's the method, the QAS method, quadrant angle sides. I don't know how to pronounce that. QAS, CAS, COS, I don't know. QAS, quadrant angle side. And then just pick what you need, X or Y or some ratio or flip. But that's the easy part. QAS will get you the picture. Let's try a couple more using the homemade QAS method. Quas it up rather than go into the unit circle. Seven pi over 6. What quadrant is that in? 3. How'd you know it was in 3?
Closer to 1/2, but it's not. And 3/4.
Yeah, I mean, I'd say it's just barely bigger than 1. So it's into the third quadrant. Is it shallow, middle, or steep? Or is it, in another way to say it, is that going to be closer to the x-axis or closer to the y-axis? Or in the middle?
X-axis.
Why do you say x-axis?
That's what you guys write down in the notes.
Because that's what I said earlier. All the over 6s are closer to the x-axis. So I'm going to draw a picture in the third quadrant close to the x-axis. And if I write this out first, I don't have to do the full picture. I can kind of cheat, and I only need the third quadrant, so I can draw my little baby picture of just one quadrant. So quadrant 3, shallow. Then I need to label the sides. Well, this is not the 45, 45, 90, so I got a short side and a long side. Every short side in the whole triangle is how long? Or the whole unit circle? All of the short sides are how long? 1/2. And all of the long sides are root 3 over 2. Let's be careful about negative. Who's negative in this one? Both of them. And then cosine. Now I'm ready to answer the question. What coordinate am I looking at for cosine? X coordinate. So my answer is negative root 3 over 2. Without having to go to the unit circle. Now, again, you've got it, and so if you answer some of these and you want to check them, then that obviously is fine. But this is going to be the better way to go moving forward. Especially the further we go into this year, you get into calculus next year, and there's like 2 questions on the test where you need to know the cosine of 7 pi over 6. Well, you don't want to draw the whole unit circle and label all the angles and find every single thing and then come to the conclusion that it's negative root 3 over 2. You just don't have time to do that. Tangent of 5 pi over 6. What quadrant's that in? 5 over 6. 2, because they're almost to 1. So usually finding quadrants isn't bad. It's just if you got a little bit of fraction sense, you can figure out what quadrant you're in. Okay, is that close to the x-axis or the y-axis? Is it the shallow, the middle, or the steep angle? It's shallow, or it's x-axis, either way you want to say that. So quadrant 2, shallow, sides, short sides are 1/2, long sides are root 3 over 2. You probably figured this out, but you got to draw the angle correctly if you want to use the short and long side thing, right? Because if you draw this as a steep angle, then who's short and who's long gets backwards. So short and long is a great way to go, but it only works if you draw the angle right. So you got to make sure you got the shallow, middle, steep thing correct before you just say, oh, short side and long side. Let me be careful here. X1 is negative. Tangent is y over x. So the y coordinate's 1/2. The x coordinate is negative root 3 over 2. So the 2's can cancel, and that leaves me with 1 over negative square root 3. I don't really like, but that's an easy fix. So root 3 over 3, and it's negative. By the way, we hadn't even talked about all students take calculus. We've just kind of let that take care of itself. But you can still use that to check the sign, the plus or minus of your answer. So you can do it either way. If you're careful labeling the sides, you don't ever have to worry about all students take calculus. If you're lazy about worrying about the sides, positive or negative, or you just don't want to worry about it, you can get the sign from all students take calculus. Either way. Let's do 2 more. Secant. Groans already. Secant of 3 pi over 4. Once you get the hang of this, you're not going to write QAS on every problem. Unless, maybe you will, but you don't have to. 3 pi over 4, what quadrant's that in? What was that? 2, because that's almost a pi. So I'm just going to cheat and only draw the second quadrant. That's the only quadrant I need. The angle, is it closer to the x-axis, closer to the y-axis, or right in the middle? The middle. How'd you know it's the middle? Because the 4. All the 4s are always in the middle. So I need to draw my angle right in the middle. Does that triangle have a short side and a long side? No, because it's right in the middle. So when the side lengths are the same, how long are the side lengths? Not 1/2, because 1/2 is the short side. Root 2 over 2. They're all root 2 over 2 if they're pi over 4. And that one going left would be negative. Okay, secant is 1 over cosine. So I want to flip the x coordinate. And again, I'm writing more than you probably will write, but maybe initially it's good to write this stuff out so that you can kind of force your brain to think through it. Once you do 5 or 10 of these, you'll still need to draw the picture, but you probably won't be writing very much. You'll just draw the picture and you'll think, let me flip the x coordinate. So that's 2 over negative root 2. That requires a little bit of fixing. Lots of 2's, so be careful. 2 root 2 over negative 2, or just negative root 2. Let's do one more. Cosecant of pi. Cosecant of pi. What quadrant's that in? Yeah, good answer. It's not in a quadrant. It's like on the line. So let's still do a little sketch. It's over here. So quadrant, no. Angle, well, not really. But we can label the point there. What point is that at if we go to the left? Negative 1, 0. Alright, cosecant. Again, some of you are not going to write much down. You're going to do it in your head. If you do it that way, I can't give you partial credit. It'll just be all or nothing if you want to do it all in your head. I do require the picture, but the rest of this stuff, if you do it all in your head, that's fine as long as you get it right. If you've got some stuff written down like flip of sine, then you're going to get some partial credit. So flip of sine, that means I want 1 over the y-coordinate, which is 1 over 0. And everybody knows that 1 divided by 0 is undefined. So your assignment today is worksheet 2, but as best you can using quadrant angle sides rather than staring at the unit circle. Okay. Again, pay the price now to learn how to do this method rather than just stare at the unit circle. Obviously, it's easier staring at the unit circle right now. Long term, it's going to be much, much better if you will learn to sketch a quick picture and answer it that way. In fact, let's do a couple together. I'll show you how I do them, show you how quick this can be. So turn to worksheet 2. Turn to worksheet 2. I'm going to work cosine pi over 3 with the QAS thing, but this time without showing every single step and making each problem last 5 minutes long. So pi over 3, that's first quadrant. Over 3 is the steep angle. So first quadrant, steep angle. I'm going to skip a step. Cosine is x. So really, I don't need all the sides of that triangle. I just need the x side. How long is the x side in that triangle?
1/2.
1/2. How'd you know it was 1/2?
Short side.
Because it's a short side. So my answer is 1/2. I didn't need the unit circle. Sine of 7 pi over 6. 7 over 6, a little bit bigger than 1. So it's third quadrant. Over 6 is the ones that are closer to the x-axis. That's the shallow angle. Sine is y, so again, I don't need all of the triangle. I just need the y coordinate. What's the y coordinate of that triangle? Careful, I want the y coordinate. That's the up and down coordinate. The y coordinate is this coordinate. And that's the short side. Positive or negative? Negative because it's down, or because all students take calculus. So when you get the hang of this method, it goes quick and you don't have to draw the whole unit circle every time. Alright, so the rest of the time is yours to work. Again, I can't control how you do it, but it'd be much better if you learn to do this with quadrant angle sides rather than drawing out the whole dang unit circle.